Hi, welcome back to my YouTube channel. Today, I'm going to look at the experiment on electricity on Neco Physics Practical 2024. So, we are asked to provide a constant time wire of SWG 26 millimeters, and the diameter of SWG of a constant time wire is 0.46 millimeters, whereas the resistivity is 5.0 times 10 raised to the minus 7 ohm meters. I'm going to use these things given to see how we can generate some readings on this electricity experiment come 2024 physics practicals. Stay tuned. But before I proceed, if you have not subscribed to my channel, please do well. Please give it a thumbs up and subscribe so we can forge ahead. Looking at what we have, we are given the constant time wire of this 26 millimeters, the resistivity as this, and the diameter as this. Now there is a relationship connecting the resistivity and diameter, and that relationship, rho, is equals to RA over L. Now we have diameter. There is a relationship between diameter and area, because diameter is pi r square, okay, and we can have it as pi r diameter over 2 all squared. Why do I have diameter over 2 all squared? Because radius is diameter over what? 2. Radius is diameter over 2, and the diameter given is given as 0.46 millimeters. If I divide it over 2, I'm going to have 0.23 millimeters, and also it is supposed to be in meters, so I'll divide by 1000. So I have 0.23 times 10 raised to the power minus 3 meters, which will give rise to 2.3 times 10 raised to the power minus 4 meters. That is our radius. Okay guys, so let's see how we can get our area. Area is pi r square. So we have pi as 3.142 times my radius to be 2.3 times 10 raised to the power minus 4 meter. We will not say meter, all squared. So I have 3.142 times. By the time I square 2.3 exponent minus 4 square is going to give me 5.29 times 10 raised to the power minus 8. I'll multiply by 3.142 is going to give me area to be 1.662 times 10 raised to the power minus 7 meter square. Now this is my area. Remember that the resistivity formula, rho, is equals to RA over what? Over length. Now if I have my resistivity, which is given as 5 times 10 raised to the power minus 7 ohm meter, I can substitute it in and get my unknown, which is my what? R and what? Length. But before then, I will divide both sides by what? A. If I divide both sides by A, R over L is equals to rho over A. What is my rho? 5 times 10 raised to the power minus 7 all over 1.662 times 10 raised to the power minus 7. Then, if I divide it, I'm going to have I'm going to have 3.01. I'm going to have 3.01. You need to be what? Ohm per meter. So now, if I want to get the values of my resistance, I will call this resistance for L is equals to L bracket 3.01. Now guys, I have different values of L in centimeters. If I substitute it in here, I will get my unknown resistance, which is R. Okay guys, so let's see how we can use this formula obtained to get the resistance for each of the lengths. Remember that this length is given in centimeters, so we're going to convert it to meter before we proceed. So we have R1 is equals to L1 bracket 3.01. So my L is 10 centimeter. I divide it by 100. It's going to give me 0.1 times 3.01, which will give me 0.30. R2 is equals to L2 bracket 3.01. Okay, so I'll convert it to meter by dividing by 100 as well. I have 0.2 times 3.01. I have 0.60. R3 is equals to L3 bracket 3.01. 0.3 times 3.01, which will give me 0.90. R4 is L4 bracket 3.01. That is 0.4 times 0.4 times 3.01, 1.20. R5, that is L5 times 3.01. So we have 0.5 times 3.01 equals to 1.51. So we're going to replace all into our values. 0.30, 0.60, 0.90, 1.20, 1.51. Okay, so we're going to use this equation that relates current and EMF. Now we are asked to find the current. Let's see how we can get the current using this equation. I is equals to E over R plus R. We want to look for the current, but we are given the EMF of 3 volts. So depending what you are using, you may have 2.8 volts, 2.95 is still correct. So you work with what you have. Now, this is the standard resistor given, which is given as what? 2 volts. So 2 ohms. So this is 3 volts, and the R is what? 2 ohms. Now, this resistance here becomes my internal resistance. I'm going to use these ones in place of the internal resistance because it is the opposition given by the flow of current within the poles of the cell. That is why I'm going to use this one. So I'm going to get the current for each of them. So I1 is equals to 3 over 2 plus 0.3. I'll have 1.30. I2 is equals to 3 over 2.0.6. I will have 0.15. I3, that is 3 over 2 plus 0.90. 1.03. I4, that is 3 over 2 points 1.2. Now 0.94. Then the last one as 3 over 2.1.51. 0.85. So I'm going to substitute it into what we have. So guys, let's proceed to get our potential difference, which is measured in volts. Stay tuned. Okay, so we can use the formula of Ohm's law to get our potential difference, which is measured in volts. Using V is equals to what? IR. Okay, I have my I now, which is current. I have my resistance. So V1 is equals to I1 R1. That is 1.30 times 0.30. 1.3 times 0.3. I have 0.39. V2 is equals to 1.15 times 0.60. I have 0.69. V3 is equals to 1.03 times 0.90. I have 0.93. G4 is 0.94 times 1.20. I have 1.3. V5 is equal to 0.85 times 1.51. I have 1.28. So we'll put in all our values: 0.39, 0.69, 0.93, 1.13, 1.28. So we are going to plot a graph of V against L. Let's see what we have. Okay, so we're asked to plot a graph of V on the vertical against L on the horizontal. So let's see how it goes. I'm going to use pen, but when you are doing yours, I'm going to use pencil. For clarity's sake, that's why I'm using pen, so I can see it clearly. Okay, so we have potential difference measured in volt, L measured in centimeter. The title of your graph, which is a graph of V against L. From what we have, let us choose a good scale. I will use 0.2 to 2 cm to 0.2 unit, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, 2.0. Okay, coming to here, 2 cm to 10 units. I can say 20, 30, 40, 50, 60, 70, and 80. So let's go. We have to plot 0.39 against 10 centimeters. Before we do that, if from here to here is 0.2, what does one line stand for? Since we have 10 calibrations here, we're going to divide it by 10, so it becomes 0.02. But one important thing you're supposed to do before we start plotting is to write your scale. This your scale carries 1 mark on each of the axes. 2 cm to 0.2 unit on V axis, 2 cm to 10 unit on L axis. Okay, so let's go. 0.39 against 10 centimeter. We have 0.33436. Okay, 0.39 against 10. I have this. The next one is 0.69 against 20 centimeter. 0.69 against 20. Okay, 0.93 against 30 centimeter. 0.93 against 30 centimeter. 1.13, approximately 1.1 against 40 centimeter. And the last 1.3, or we can say 1.28, 1.28 against 50 centimeter. Okay, this is 28. Okay guys, this is what we have. Let us join our point. And when you're joining a point, remember your line of best fit, because your line must not be, all the line points must not be on a line, but the ones that are not on the line must be evenly distributed. So I will join my line. Once this line is correctly drawn, you already have 1 mark for drawing the line. This is line of best fit. You recognize, or you note that this point and this point are evenly distributed. 1 point on this side, while the other on the other side. So let us join to find our slope. Okay, you can decide to extend it. So here we have change in V against change in L. This is in volts, while this is centimeter. So I can say this is L2, L1, V1, V2. So let's proceed to solve for our slope. Okay, let's solve our slope. Slope is equals to change in V over change in L. This is volt, while this is centimeter. That is V2 minus V1 over what? L2 minus L1. So from what we have, our V2 is 1.54. I have 1.54 minus 0.54, 0.54 divided by 63 minus 12. So with our calculator, we have 1.54 minus 0.54 is going to give me 1 over 63 minus 12 is going to give me 51. So by the time I divide 1 over 51, I'm going to have 0.019. I'm going to have 0.019 volts per centimeter. So guys, this is the slope of the graph. If you are asked to find the intercept means where this line of best fit is touching the vertical axis. You just note the points and write the value for them. I hope you love this video. Please do well to subscribe to my channel, follow my page. I hope it will be of great value to students and teachers. See you next time. Thank you.